Welcome to Sheridan College's Industrial Process Control. This video is part of Lab 2, Continuous Level Measurement, and is the first part of the total process, calibrating a pressure transmitter in preparation for the lab continuous level measurement. In order to successfully complete the continuous level measurement lab, you must prepare the transmitter. This applies to any lab or field work where transmitters are being used. The basic three steps are 1. Setting up the equipment, which includes the proper location and mounting of the device, making the signal connections, and connecting the fluids involved. The second step is to purge or blow down the transmitter of any unwanted fluid or debris that may have entered the device. The third step is once purged, the transmitter must be calibrated in situ, or where it's going to be used, since the hydrostatic pressure is directly related to the elevation of the device relative to the process fluids involved. Begin by securing the transmitter where it needs to be. In field work, this may be the same location as a transmitter you are replacing, while in new installations, be sure to follow any blueprints and mounting instructions provided by the manufacturer. Since location is critical to correct operation, be sure to double-check any instructions, and if any doubt remains, ask the appropriate person in charge. In our case, the transmitter will be mounted on the metal pegboard as indicated. Use the magic peg wand on the yellow banded peg and rotate 90 degrees clockwise until the red flag disappears. Then check that the device will not move.
Okay, you've been given our lab. You've probably gathered a couple of parts. This transmitter is worth a couple of $1,000s. We don't want to drop it. So we're going to show you how to mount it properly. You may notice that there are 3 black pegs and a yellow peg. On the back are red hangers, and if you look really closely, you'll find there's a notch. That's to allow that to go through the hole and then slide over. So what we want to do is we're going to start off with the device having all of the holes lined up in the same direction, and you'll notice that there's a flag pointing on the side. I'm going to take that, mount it on the holes I want, and I'm going to give it a little shove opposite the direction of the flag. Then I'm going to take the tool we have, that should be on the corner of every station, and it has a indentation on one side. I'm going to cover that up, and I'm going to rotate that 1/4 turn. So now it's no longer pointing this way, it's pointing up. It shouldn't move. When I go to take it away, I look at that flag. If it won't move, that's a good thing. It should not take any force to give it a 1/4 turn. That tells me the direction I'm going to move the unit to remove it. It's just that simple.
Now that the device is mounted and cleared, you can proceed to the signal wiring. Follow the wiring diagram. The one that has been provided has been simplified and does not represent a normal set of electrical prints. Always follow the manufacturer's information, usually provided with the device, and again, if any doubt remains, ask a person in charge or do the research. Transmitters can cost thousands of dollars and are very accurate devices if installed properly. Wiring them incorrectly can do severe damage to them. So always be sure to observe polarity, keep your wiring and terminations neat so that you can double check your work easily, and it makes it easier for future troubleshooting. And always make sure you use the correct wiring method. The transmitters used at Sheridan can handle both 0 to 5 volts DC and 4 to 20 milliamps. For introduction instrumentation, you use the 0 to 5 volts DC. For this course, you'll be using the 4 to 20 milliamps. Keep this in mind as this will introduce a signal offset into your calculations. The power for the lab will be provided by the 24 volt taps on the Brian brush control panel. If the station you are working on does not have the control panel, then you will use the 24 volt power supply. Notice that you will need a digital multimeter set to milliamps. This means you must wire the meter in series with the monitored signal to determine the current. You will be required to monitor the digital multimeter during calibration. You can mount the digital multimeter to the receiving tank by carefully using the probe holding clips located on the back of the meter. Simply take the meter and align one of the probe holding clips with the aluminum tie rod on the receiver tank. Starting from the top of the holding clip, apply firm but not forceful pressure to insert the tie rod into the holding clip starting at the top of the clip, and then rotate the meter downward until the meter is fully secured. This will allow you then to slide the meter up or down for easy viewing. Once the wiring is complete, move on to the piping. On the diagram, the green process lines represent the supply piping, while the brown lines represent the return piping. The black process lines are not used in this lab. The two permanently attached hoses to the holding tank cart are sufficient for this lab. On the calibration video, an additional hand valve and small feeder hose is added to the supply piping. This allows the technician to close the valve and trap the water at a particular level while doing the calibration. This P&I drawing shows the final drawing used in the continuous measurement lab, whereby the additional hose and valve are not used. In our lab, every device that allows liquid flow has a quick connection port. To avoid getting wet or creating a leak, inspect the black O-ring on the port to see if it's there and is in good condition. Tell the instructor if you find one missing. On the receiver tank, you will be using the two bottom connection ports. Check them first before making connections. The process lines used in our lab have a quick connect-disconnect fitting. To install the hose, simply align the hose with the port and push it in. To release the hose, pull back on the orange ring and then give the hose a slight tug. If the hose leaks after installation, make sure that it is completely inserted. If it still leaks, drain the system and remove the hose to inspect it. Check that the knurled ring has been tightened. If after reinstallation and reapplication of water it still leaks, drain the water back, replace the hose, and notify the instructor of the defective hose. You will need 3 impulse lines for this lab. One will be for the low pressure signal, which in this case will be provided by the trapped air above the control variable water in the receiver tank. Another will be used for the high pressure signal generated by the hydrostatic pressure of the water in the receiving tank. A third one will be used to purge or blow down the high and low pressure ports of the transmitter so that there is no unwanted fluids or debris in the transmitter to affect calibration. The transmitter will be performing as a differential pressure transmitter. That is, its signal will indicate the difference in pressure between its process ports. On the transmitter itself, there are 4 quick connection ports. The ports located on the side are the process ports, while the bottom ports are for blowing down or purging. The right-hand process port is for the expected high-pressure process connection, while the left-hand process port is for the expected low-pressure process connection. All of the impulse lines used in our labs have spring-loaded retaining clips. These must be engaged properly to hold the lines in place and to release the spring-loaded internal check valve so that the fluid can flow. On the plastic fittings, you will find a red plastic retention ring. The impulse lines must be inserted far enough that the spring clip can engage with the red clip. Like the plastic quick connect ports, the metallic ones has a retention feature, but here it is a machined groove. The impulse lines must be retained by this groove to overcome the internal check valve and to ensure proper reading.
We're going to blow out the trapped air in the system. To do that, we're going to use a blow-off line. We're going to put one end into the tank, the other end into the high-pressure blow-off bleeding valve port. Make sure it's snapped into place. Right now our tank is empty, which means our high-pressure impulse line is full of air. So we're going to make sure the valves are open. I'm going to turn the pump on, and we're going to fill it up to about halfway. As the water is starting to go through, I'm going to shut the air off or close the valve. So the water is trapped. Right now we have water in our high pressure port, and we have water draining out of the bleed off line. So that's taking all of the air out. Once you bled that out, just snap that out, the check valve will close, and the impulse line will be clear.
Once the transmitter is mounted, zero out or clear the transmitter's zero trim potentiometer or trim pot and the span trim pot by rotating them clockwise until they stop turning. This may be 3 or more complete revolutions. Do not manhandle the trim pots, as this can affect their sensitivity and damage them. Remember, this is not a race. Out on the field, you'll be paid by the hour, not the piece. And any careless workmanship is always far more expensive than a few saved seconds of effort.
The next part, we're going to start calibrating our pressure transmitter. And to do that, we're going to set the water down to a lower level. The first thing we have to do is set our zero and our span switch to maximum. So we're going to turn that clockwise, both of them, and in each case they should take about 14 half turns to get it to go to completely maximum until you hit the stop. Don't overcrank it, just apply equal pressure. Don't try to spin it too fast, take your time, it's not a race. Once we have that, we're going to lower our water down to approximately 2 inches. So that gets down to 2 inches. We're going to close the valve and close the return valve just to make sure that no water leaks. In this particular case, there may get a small bit of leakage from the actual fittings. For the most part, we are at 2 inches. Now we can begin our calibration. So we have an amp meter in series with a 250 ohm resistor, and we're going to use it to determine our current output. So right now we've set our zero up to maximum, which is way beyond what we want. So we're going to dial this down, and it's going to start dropping. And we want to stop it as the second it gets as close to 4 milliamps without going under. And we're not moving the dial quickly, we're just taking our time. When you get close to 5 milliamps, you're going to slow down and take your time to get it down as close to 4 without going below. So I'm now at 5, so I'm just going to move it just slightly, let it stabilize. So I'm at 4.02 milliamps, so I'm going to leave it there for now, and now I'm going to add more water and bring it up to our upper level. So once I reach 20 inches, I'm going to stop the pump. Let it come back down to 20 and stop it by closing the valves. So right now I'm a little bit below. I'm going to pump a little more up. Let it come back down and stop it at 20 inches. Now I'm going to adjust my span. So I'm going to do the same thing. I'm going to rotate this, and the number should start to climb. And our goal here is to get it up to close to 16 without going over. Pardon me, 20. So I'm at 19.89. Now we're going to go back and redo our zero. We're going to repeat the same process 3 times. So I'm going to open up the valve to drop the water. And we see our value is starting to drop. Because we've adjusted our span, when we get to our zero, which is 2 inches, we should see that the number may not exactly be close because each one will affect the other. So we're at 3, 2.5, and 2. So at 2 inches of water column, and my reading is at 4.02. So I'm going to try and get it down a little closer. Okay, it doesn't seem to want to move, so now I'm going to pump it back up to 20 inches. And drain it back down to 20. So I'm a little bit low. I'm going to try and improve that. So you keep repeating this. You'll do this about 3 times until you get it as close to 20 as possible and as close to 4 without going beyond those. So I'm at 19.91. Go check our zero again. while the water is going down, the chart that you prepared last week, you should be able to get a gauge when it gets to around 10 inches, around 6 inches. You can check your numbers and see if you're close. So we're down to 3 inches, 2.5, and 2. And I'm still at 4.02 milliohms. So pumping it back up again. And we're at 20. And we're exactly 20 milliamps. So I would say this has been calibrated, and you can move on to the next part of the lab.